In this example, we are looking at the function dy by dt is equal to 3y times the quantity y minus 2. In this example, we see that there are two equilibria. This would be at the points y equals 0 given by the 3y, and also at the point y equals 2 given by the function y minus 2. So when we're creating our phase line, we already know that our equilibria are going to exist at y equals 0 and y equals 2. So if I put my equilibria line here, I'll have y equals 0 and y equals 2 will be my equilibria. So it will not have any movement of functions within there. So at this point, all I need to do is just take some arbitrary value in each of these regions. Region 1, region 2, and region 3. Region 1 will be y less than 0. Region 2 will be y between 0 and 2. And region 3 will be y is greater than 2, or 2 is less than y. In these regions, all I need to do is look at our function dy by dt, plug in the value, and see if the differential is positive or negative. And that will allow us to understand whether our equilibria y equals 0 and y equals 2 are sinks, sources, or nodes. So in our first example, y is less than 0. We'll take the arbitrary value y equals negative 1. We'll plug it in our solution. 3 times y is negative 3. Negative 1 minus 2 is negative 3. Negative 3 times negative 3 is 9, which is 0. So that tells us that for all y equals 0, our differential is positive. So we'll put that in our phase line. Now we'll look at our other regions. Between y equals 0 and y equals 2, we will use y equals 1 as our arbitrary value. Plug that into our solution. We have 3, 1 times the quantity 1 minus 2, which would be 3 times negative 1 equals negative 3. So we understand that all functions within here are going to be negative. So we will add that to our phase line. And then we'll take an arbitrary value in our third region. Y is greater than 2. We will do y equals 3. In our function, we have 3 times 3 times the quantity 3 minus 2, which is equal to 9 times 1 is 9, which is greater than 0. So in this region, we understand that all functions will be positive. So lastly, what we have to do is look at our equilibria again, and we can tell whether they are sinks, sources, or nodes. So if you look at our first equilibrium point, y equals 0, we see that we have all solutions are directed to y equals 0 from the local area, because this is coming up to it and this is coming down to it. So this would be a sink. And then our other equilibrium shows all local solutions pointing away from it at y equals 2. So this would be a source. So that is how you solve this problem, and that is how you sketch the phase line to understand the local behavior for this solution.